Hi everybody. So we're going to try to cover related rates. I already shot a video for this, and I tried to just do a brief explanation with one example, and it took like 45 minutes. So I have to try to chop this up into smaller pieces. This is difficult for remote, but I'm going to try to make this this video one, what you're watching now, is going to try to address just what is a related rate, what does it mean, and I'll set up the first equation, but we're not even going to start it. I'm just going to set it up. Video 2, we'll kind of get into solving our first problem, right? And then when we're all done with this, I'll give you a couple examples that are just like the ones I'm doing for an example, and all I want you to do is try to duplicate my work just with different numbers and alterations. Okay? So first let's start out with what related rates are. Related rates. So I'm going to type up some notes on what I'm writing on the board right now, but it's nice to be able to talk through it while I'm listing them. So related rates, we are finding how fast something is changing. Now, this is hard for people to get their heads around. It's a quantum leap forward into abstract thought mathematically, because usually what we do we don't find out what it is. Normally we find out what is it, right? What is the height? What is the diameter? What is the frequency? Whatever it is you're trying to find. What is the angle? Here, I'm not talking about what it is. I'm talking about how fast is it growing? How fast is it shrinking? How fast is it changing? I don't care what it is right now so much. I care how it's changing. What does that even mean? Let me try to give you a couple examples. So before we start dealing with numbers, just what am I talking about? Think about a video game where you got to level up. So let's try to make a number line, right? And we're going to visualize levels versus experience, right? So when you start out, let's say this is, you start the game and you're level 0. Or level, you start on level 1. So usually they make games so you progress through the first few levels pretty quickly. And then they start to spread out. And eventually it takes a long time to gain one level. So let's say this is when you're on level 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and so forth. Now, at any one point in time, I could ask what level you're on. That's what the level is, right? So let's say on Monday, I'm on level 1, and you're on level 2. Now, at that point in time, we're one level apart. Let's say on Friday, I'm on level 11, and you're on level 12. So I'm here and you're here. Well, both days we're one level apart, but that's not really the same, is it? See, sometimes it doesn't really give you the full picture to just give the concrete surface level facts. Sometimes you've got to go a little deeper, a little more abstract. So when I'm only one level apart, when it doesn't take much to change a level, a small rate of change in experience to get to the next level, that's not as big of a difference as when up here it takes much more experience to get a level. The rate at which I change levels is much slower here. The rate at which I change levels is much faster here. See, that's what we're talking about in rates of change, is not what level are you on, how fast can you progress to the next level. See, that's the next layer in abstraction, and that's why it takes a little bit of time for people to really grab hold of, because that's not where we start in math in school. We got to build up to there. Let me give you another example. And this is going to feed into our first example problem where we'll actually calculate it. Think about, so the first example problem we're going to do is think about a mine like over here on Quarry Road. They got to take all that dirt away from the hole. So sometimes what they do is they put it on these huge conveyor belts and some machine dumps the dirt on it and that just carries it away and drops it off in a pile somewhere. For simplicity, let's say we don't even got to worry about the shape of the pile yet. So let's say this is at the beginning, and here's the conveyor belt, and sand is falling off. Now what I want you to think about is the height of the pile and how fast the height is changing. I want you to think about those two concepts. They're similar, but they're very different. To make this easier, let's forget the conveyor belt. We're going to do that in our problem. Instead, let's say what I do is I go to Lowe's and I buy one bag of dirt. You know, they're big, like a 50-pound bag of dirt. And I take that bag and I rip it open and I pour it onto the ground. So at first, 0 bags, I'm writing too small. 0 bags of dirt had a 0 foot high. There's no pile, so it'd be 0 feet. Then I put 1 bag of dirt down. And let's say it forms a pile this big. And let's say I measure that height, and that gives me a 2-foot high pile of dirt. Right? So 1 bag generated 2 feet of height. It made a 2-foot high pile. Okay, let's say I put 2 bags on there, a second bag. So that's already there. I put the second bag on. Now what's going to happen with the second bag? It's going to spread that out, right? So it is still going to gain height. Maybe it'd do more than that. But a lot of that dirt, all the dirt doesn't go into the height, it also spreads out. So some of it goes for the height, but some of it spreads all over the surface of the pile. So maybe that is only now 3 feet high. Right? Now let's say I had done this for a long time, so the 4, 5, 6. Let's say after 10, so this is 9 bags. By the time I have 9 bags of dirt in a big pile, if I put 1 more on, that's not going to increase the height very much at all, because all that dirt has to spread out over the whole pile. So I'm only going to get an itty bitty rise in dirt. So on my 10th bag, you know, maybe it's only like 6 feet high. Right? At first, it grew by 2 feet, and then it was 1 more foot high. Well, it took 7 more bags just to get 3 more feet of height. See, the rate at which the height is getting bigger is slowing down. The height is always getting bigger all the time, but the rate at which the height grows is decreasing. See how it's layered? The height is increasing, but the rate at which the height is increasing is decreasing. That takes a little while before that language and that logic is easy to follow all the time really quickly, right? Hopefully when we're walking through this makes sense when you kind of go slow. Here, let's try another one. Instead of making a pile, let's drain water. Let's say like a coffee filter. Most people have a coffee filter in their house, although a lot of them aren't shaped like this. But let's say you have a cone-shaped coffee filter, and you fill it with water. So the water's up here. Now, for a second, I want you to close your eyes and visualize if you've ever seen water flow out of a funnel like this. I want you to think about what that looked like. If you can't, if you have a funnel in your house, do this, or try to find a video where you can watch the water flow out of the funnel. So what happens is, in 1 second, it won't drop very much, right? So it'll drop a little bit. But because this is getting smaller and smaller, I'll just say because that is true. So in the second, it's going to drop more than this. So this is my first second drop. I should bump that up a little bit. This is my second drop. And in my third second, it really starts speeding up. If you've ever watched it, you see it goes slow, 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 and then it just picks up speed, zoom, and it's out, right? So after we've done a few problems, we can talk about why that happens, and it makes total sense, like it's very obvious why that happens. But for now, I just want you to realize that it's true. Look, the rate at which the height, so let's say that this was like 6 inches high, like at first, and then after 1 second it was like 5 inches high. So this is start. This is after 1 second. After 2 seconds, let's say it was 3 inches high. And after 3 seconds, it was 0 inches high. It was completely drained. I'm talking about the water. The water inside was 6 inches, and then it was 5 inches, and then it started picking up speed, still 1 second at a time. Now it's only 3, and then in the third second, all of it flowed out. So I could say the rate at which the height is falling is increasing. The rate at which the height of the water falls is speeding up. The rate at which the height is falling is increasing. Okay, that's a tough idea. Let's call it good there. I'm going to end this video here just on the concepts. So when we start getting into the videos where we're doing a problem, you can swing back to just this part of it if you want to just think about what it means. All right, so I'm going to stop it here. We'll call this video 1 for related rates.